Hello guys, if you like my awesome gaming videos, my programming and web development courses, my editing courses and editing videos, and my tech talks and tech guidance, then you can consider subscribing to my channel and click on this bell icon to stay connected with me all the time. Hello guys, welcome to my channel. So in this video I'm going to talk about the most important circuit analysis technique, which is mesh analysis. So I highly suggest you to watch this video if you are really a beginner. Watch my previous video where I talked about KCL, KVL, and work with the Ohm's law, V is equals to IR, and how you prove it, and current divider rule, voltage divider rule. So those are the things that are really important before understanding this mesh analysis. In the previous video I also talked about the nodal analysis and supernodal analysis, which are also really important for you guys if you want to know about different kind of circuit analysis in general. But in this video I'm going to particularly talk about in briefly the mesh analysis. Okay, and as you know, in the mesh analysis the most important thing is to loop through this using the KVL, and we apply KVL rule for each of the loop. Here we have three loop, this loop, this loop, and this loop. We have three different loop. We will have three different equation, and we're gonna solve those three unknown variables, and we're gonna get this ultimate result. What we want is actually the current system. If you want to find the branch current or the loop current here, we have to use the mesh analysis. And one more thing is that we apply Kirchhoff's voltage law. Means the summation of all the voltages in a closed loop circuit is equals to 0. We're going to apply the Kirchhoff's voltage law in detail here, and you're going to see how powerful it is. And also the main important thing that you want to find the current I is flowing through this, how much amount of current is flowing through this 8 ohm resistor very easily, because we can't find the equivalent resistor here because we have two voltage source. As you can see, two voltage source, so we can find the equivalent resistor and use the V is equals to IR format. So as you know, I is equals to V divided by R. We can find it very easily. Okay, we can't do this. In this case, the mesh analysis is really important to understand how much amount of current is going from this, how much amount of current is going from this, and this resistor. All of those things can be calculated very easily using the mesh analysis. So that's why the mesh analysis is super important. So first step is we need to just loop through this closed circuit. We have three closed loop. We will have three meshes. So in the mesh one, we'll have, suppose the current is flowing through this clockwise. You can take it clockwise or anti-clockwise, but for the normal convention, people take it as clockwise from the right to left. So this is another one, and this is another one. We can call it IA. You can call it I1, but I'm calling it differently, IB and IC. This is for the mesh 3, this is for the mesh 2, and this is for the mesh 1. Now we need to work with the polarity. Now as we are assuming that we are going from the right to left, we are going through this direction to lower to upper, and here as you can see we are just traveling like left to right, like this way. So I'm assuming this is positive polarity, this is negative polarity. Okay, now let's calculate it. So in the mesh 1, or as you can see, this is the loop 1, you can consider it. So in the loop 1, what we can do, first travel it. So we are traveling it here, current is going from there. So first we are entering from the negative sign of the voltage source, so we can consider it negative 40. So direct voltage source is directly given, which is minus 40 here. If we are entering like from here, suppose if we are going from the left to right, then we are going from the positive side of the voltage source, then it would be positive 20. But as you can see, we are taking all the thing from the clockwise direction, from this direction. Okay, from this direction. So all things are this direction. So we are entering from the negative portion of the voltage source, so it is negative. Always remember that. And then we are going to the 2 ohm, and we're gonna go plus. Then we need to find the amount of voltage difference here. So this R is already given, which is 2 ohm, and what is the current is there is IA. So IA times 2. Okay, so V, this is total is V, voltage difference, which is IR. So this is the actually Ohm's law that we are applying here. So this is actually V is equals to IR. So I is the IA current, this is the loop current that we're going to find, this is the unknown thing, and the 2 is the 2 ohm resistor. Similar, Then the most toughest thing is here. This is the most tricky thing. So we are going from this one to this one. So we are considering this is a positive polarity, this is a negative polarity, because we are going from this to this, from this one, from upper to lower, and then we are going from the minus 40. So minus 40 plus this one is very simple because no other current is flowing from this. So it is 2 times IA. Okay. And then we need to just go from 8 ohm resistor, but 8 ohm resistor, there is also IB is also going from the lower to upper. Okay, from low to upper, but this 8 ohm resistor, this current IA is going from the up to low. This is the positive side, from the positive side to the negative side. So from upper value to the lower value it is flowing, but the IB current is also flowing from this. So there is a problem here, there is a contradiction. IS current from the top to bottom, IB is going from the bottom to upper side, bottom to top. So what we can write here, so the main formula is that we are working with the IA, we are working with the loop 1 or the mesh 1, so this should be the leader. So we will write IA minus IB, okay, assuming that this is the higher potential, this is the lower potential. So we're assuming this IA is the leader, and we're gonna minus negative whatever the value we got from the IB. Then we get the value of whatever voltage difference, the voltage drop across this 8 ohm resistor, and this is the current I times R. So this is the voltage drop across this resistor, which is IA minus IB times 8. Okay, so if we would be working, if I work with the IB, it would be IB minus IA times 8 if we work on this mesh 2. Okay, so the total is actually 0. So this is what the Kirchhoff's voltage law says. The summation of all the voltage source in a closed circuit is equals to 0. So the final answer would be 10 IA minus 8 IB is equals to 40. So this is our equation 1. Okay, so equation 1, simple. And then we need to work with the equation number 2 or the mesh 2. So if you calculate it, you will get this answer. So our equation number 1 is complete. Now we need to work with equation number 2. Here we have to think it a different way. Okay, suppose we are taking the current is flowing from this one, and this one. Now 6 ohm resistor, there is no interference. It is very simple. Just write positive polarity, negative polarity, because the current is flowing from this to higher potential to lower potential as we are assuming it. Okay, and as you can see, the current is flowing from this for the IB. So we can assume this is positive polarity, this is negative polarity. As you can see, there's contradiction. When we are considering the IA current, it is positive and this is negative. But when we are considering IB, it is going from this side to this side. This is the higher potential to lower potential. The current is flowing from this bottom to top. So this should be the plus, this is minus. And so this is the thing that we need to work on. And similar to IC, this 6 ohm resistor is between IB and IC. So similar to this concept, as we are working with this is IB, and this is the positive polarity, this is the negative polarity. And for IC, it should be the opposite, similar to that. Now let's calculate it. So first we need to work on this. The IB current is going from this 8 ohm resistor, and IA also going from the upper to lower, and IB is going from the lower to upper. So there is contradicting, but we're working with the IB. So IB is the office boss here. This is the main boss. So we have to work with this. First one is IB minus IA times 8. Okay, and then we need to work with this 6. There is no problem here. 6 times IB. So IB times 6. And then we need to work with this 6 ohm resistor. But 6 ohm resistor is between IB and IC. IB is going from the top to bottom, and IC is going from bottom to top. So as we are working with IB, it should be the leader. So IB minus IC times 6, total 0. So minus 8IA plus 20 IB minus 6 IC is equals to 0. This is our equation number 2. Simple. Now let's work with mesh 3. Now for mesh 3, this IC is the leader. Okay, so let's work with this. So IC is the leader, so this should be the positive polarity, this is the negative. So IC is the leader, so IC minus IB times 6. Plus 4, this is singular, so 6 times IC. This is very simple. It should be 4 times IC. And we have 20 volt resistor, and we are going from this is the positive polarity, this is the negative polarity, from positive to negative, so this should be plus 20. Total 0 for the Kirchhoff's voltage law. So what we get here, so we can calculate it. 6 minus 6 times IB times 6 plus 4, which is 10 IC minus 6 IB is equals to minus 20. So this is our equation number 3. So you can use calculator or any other method. You can use matrix method to solve these things. I know it is really easy for you. You can use calculator or any other method to solve these 3 equations. We have 3 unknown, okay, 3 IA, IB and IC, and 3 equations. We can easily solve those things very easily. So you can, after solving all those things, you will get the answer like IA is equals to 5.6 ampere, IB is equals to 2.0 amperes, and IC, which is minus 0.8 amperes. So as you see, the IC is minus 0.8 amperes. As you know, the current can be negative, but why it is like negative? Why it is negative? It is because it is going from the opposite direction where we assumed. It is going to the opposite direction. Okay, so in the beginning we just presume that everything is going from the clockwise, but here, as you see, this is the positive side of the voltage source. The current should go in the practical sense from this side to this side, from the left side. It should go from this side to this side, but actually we assumed it from the left to right, like this, clockwise, but actually in the practical sense it is going from the left side. So that's why we assumed it to going from the left to right, but it is going from right to left. So that's the reason it is negative value. Okay, because we assumed it from this one, but actually it is going from the left to right. Okay, so this is the thing that we assume. So assumptions and practical cases can be a little bit of different. But for IA and IB, it is a positive value because our assumptions and practical sense is also similar. It is going from this left to right, and also this is from the left to right, like this. Okay, so what is the questions here? We want to find the voltage difference across this 8 ohm resistor, like V8. We call it V8. So voltage difference across 8 ohm resistor. What should be the answer? The answer is the current is IA minus IB times 8 ohm resistor. Times 8 ohm resistor. So what is the value of I, which is 5.6? What is the value of IB, which is 2? Times 8. We got 28.8 volt. So the voltage difference across this 8 ohm resistor is 28.8 volt. We can find it really easily because we know the 8 ohm resistor, the value of the resistor, and also the value of IA current, and also the value of IB, the current that is flowing in the mesh 2 and the current that is flowing on the mesh 1. We know all of those loop currents. That's why we can able to find the voltage difference across this resistor. We can find it for any of this, like 6. For 6 ohm resistor, it is very easy. We can easily find it, which is 6 times IB current, which is 2, which is 12. Very simple. And the voltage difference, which is 12 voltage drop, actually it is 12 volt, and the V8 is equals to 28.8 volt. This is the voltage difference. And if you want to find the voltage difference across this one, let's calculate it. And we know this voltage difference across this is IC minus IB. You can also calculate it, or you can also calculate it IB minus IC. Any of this thing would work just fine. So IB value minus IC times 6. If you calculate it, you will get your answer. Okay, so if you just need to find the IA, IB, IC, and you find the voltage difference or the voltage drop across any of the resistor here or any of the component, it is very simple and easy stuff. What you need to find the loop current IA, IB, IC. You can get everything being very simple and easily. In summary, what you have to do, it is very simple. You just need to find the how you just traverse along it, and when you find this one resistor is having two current which is contradicting, which is IA is also flowing from it, IB is also flowing from it, you just need to subtract it. And if you're working with the IA, it is the leader, and IA minus IB. When you're working with the B and we're working with this, and IB is the leader, IB minus I is equals to 8. And when we're working with C, that's IC minus IB times 6. So this is the thing that you need to work really hard on to identify it. This is the complicated stuff that you need to work. This is nothing complicated, but some for beginners it would be a little bit of complicated thing, but this is the most efficient way to find any node voltages or any branch current or voltage drop across anything. This is the universal law you can use mesh analysis that works on many different kind of circuit. Any circuit can be solved within the mesh analysis. So that's why it is the one of the most powerful technique for DC circuit analysis. Understand it properly and share this video and like comment as much as possible, because after this I'm going to talk about more advanced thing, which is Thevenin and Norton analysis. Thanks for watching. I will see you in the next video where I'll talk about much more advanced topic in the near future.